The Atlantic low developing near Ireland is a classic example of rapid mid-latitude cyclone intensification driven by a strong temperature contrast between cold polar air and warm subtropical air over the ocean. As this system moves into an area of powerful upper-level jet support, rising air is efficiently evacuated from the storm's core, allowing surface pressure to fall quickly. This rapid deepening strengthens the circulation and dramatically increases wind speeds around the low. As the pressure drops, the surrounding air accelerates toward the center, producing widespread gale conditions and potentially damaging gusts along exposed coastlines and higher elevations. At the same time, the storm acts as a pump for moisture, drawing warm, humid air from the Atlantic and forcing it upward as it encounters land and terrain. This process enhances rainfall intensity, especially in windward regions where hills and mountains amplify precipitation through orographic lifting. The combination of strong winds and heavy rain increases the risk of power outages, transport disruption, coastal flooding, and river responses. Because the system is large and energetic, impacts are not confined to a single country, but spread across multiple parts of Western Europe as the storm evolves and shifts position. As the low-pressure system deepens and consolidates near the British Isles, the pressure difference between this storm and surrounding higher-pressure areas increases sharply. This creates a very steep pressure gradient, which is the primary driver of strong winds. Air naturally moves from areas of higher pressure toward lower pressure, and when the gradient is tight, that movement accelerates dramatically. In this case, the isobars are packed closely together across the UK, Ireland, and parts of northwestern France, indicating fast-moving air at the surface. The orientation of these isobars is also critical, as they approach the coastline almost at a right angle, allowing the strongest winds to transfer directly inland rather than sliding along the coast. Exposed headlands, elevated terrain, and coastal regions are especially vulnerable, where gusts can reach storm force. These winds can uproot trees, damage roofs, disrupt power infrastructure, and create hazardous marine conditions. Combined with already saturated ground, even moderate gusts can cause trees to topple more easily, increasing the risk of blocked roads and prolonged power outages across affected regions. The intense rainfall threat is being driven by a long, narrow corridor of moisture transported directly from the subtropical Atlantic into Western Europe. This moisture plume contains exceptionally high water vapor content and is sustained by strong, low-level winds feeding into the storm system. As this air mass reaches land, it is forced to rise, both due to the storm's dynamics and because it encounters mountainous terrain. This upward motion cools the air rapidly, causing large volumes of moisture to condense and fall as heavy rain over relatively short periods. Western Scotland, Northern Ireland, and coastal Norway are particularly exposed because their mountain ranges sit directly in the path of the incoming flow. Orographic enhancement significantly boosts rainfall totals, often doubling or tripling amounts compared to lowland areas. When this level of rainfall falls onto ground that is already saturated from previous systems, surface runoff increases quickly and rivers respond rapidly. Smaller catchments can rise within hours, while larger rivers may continue to swell even after the rain has eased, creating an elevated risk of flash flooding, landslides, and infrastructure strain across vulnerable regions. A dominant high-pressure system over Eastern Europe is fundamentally altering the large-scale flow across the continent by blocking the eastward progression of Atlantic weather systems. Under this high, air is sinking rather than rising, which suppresses cloud formation and precipitation while allowing cold air to pool near the surface. Because the system is nearly stationary, there is little mixing with milder air masses, enabling temperatures to fall steadily, especially at night. Snow cover plays a critical role by reflecting incoming solar radiation and reinforcing surface cooling, helping to maintain extremely low temperatures over a wide area. As a result, interior regions of Scandinavia, the Baltic states, and western Russia experience prolonged periods of severe frost, with daytime temperatures struggling to rise and nighttime values plunging even further. The stagnant nature of the air mass also promotes temperature inversions, where colder air becomes trapped at the surface beneath slightly warmer air aloft. This can lead to persistent ice fog, poor air quality, and hazardous travel conditions, particularly in valleys and urban basins where cold air accumulates most efficiently. Across central parts of Europe, the atmosphere is caught between two very different air masses, creating a zone of sharp thermal contrast and unstable forecasting conditions. On one side, milder and moisture, rich Atlantic air is pushing eastward, while on the other, dense continental cold remains locked in place near the surface. When warmer air is forced to glide over colder air at low levels, precipitation can fall through layers of varying temperature, leading to complex outcomes. Snowflakes may partially melt and then refreeze on contact with subfreezing ground, producing freezing rain or sleet that coats roads, power lines, and trees with ice. Even small amounts of this type of precipitation can cause major transport disruption and infrastructure damage at the same time. Persistent high pressure suppresses vertical mixing, allowing low cloud, fog, and haze to become trapped near the surface. In valleys and basins, this stagnant air can accumulate pollutants, reducing visibility and air quality. These conditions often linger for days, creating dull, gray weather with minimal daytime warming and heightened safety concerns for travel and public health. As we bring this forecast together, the message is clear: Europe is entering a period of sharp contrasts and heightened risk. Powerful Atlantic systems are delivering severe wind and rain to the western margins, while a stubborn high-pressure block is locking eastern regions into deep, persistent cold. Between these extremes, central areas face complex and potentially hazardous conditions, where small changes in temperature can make a big difference on the ground. This is a reminder that weather is not just about headlines, but about understanding how large-scale patterns translate into real-world impacts for communities, travel, and infrastructure. Staying informed and prepared over the coming days will be essential as this dynamic setup continues to evolve. Good luck to everyone in the affected regions, especially those facing severe weather or extreme cold. Thank you for watching, for trusting this forecast, and for staying engaged. Take care, stay safe, and we'll see you again with the next update.